Hello. Okay, I'm live. So let me first tweet it. On today's live stream, I am going to continue testing entry point. Oh, join me. Yeah. Okay. Post. Now that's the. Okay, let's start. Let me first open. Okay, let's start this countdown. Timer start. Okay. So yesterday we tested few things, three functions. Now we can first find out, like, go to Solidity matrix, go at the bottom, contract summary, and then this. Okay, we can test this also. Emit prefund, emit user operation, event, emit prefund to low. These two functions are internal, so we can put it, like, expose them. Now what's next? Envelopes, no. Get, we have tested this. Get required prefund. Get validate account prepayment. Let's see what this. Okay, validate account refund, account validate user op, and then this will. We can do multiple things here. Can we? So we have invalidate user op. Let me go to our account, simple account contract. So we get user operation, this. In the call data, we can modify call data so that, yeah, so we'll create the same thing, like, the same contract for our testing, and then modify this, where we are going to return, like, if first we are going to parse the call data, like we need three things, which is validation successful, validation failed, and then validation throws an error, which is here, like this condition. So, or I don't know, we don't need two conditions, we just need one condition. uh, just a second. Okay, so we need a validation data. It can be success or failure, it doesn't matter. So if pay address equal to 0, it'll check this. uh, it'll check the balance. If balance is more than required prefund, then it'll give us a value. Okay, uh, I know how to test it. Explaining it is a bit hard. So let's see. We can go here. Yeah, we can do these two functions, and then which function I said? Okay, get rig. So it takes all the values that we passed, and it returns. We also need to create this. So memory user operation. It should be an I entry point. No, it is not. So go to definition. Okay, memory user operation. All these values should needs to be there. We can create this function. Okay, we know which things to test. So emit user operation event. Go to definition. Okay, I don't know why it's not working. Yeah, so this is just simple function. This emit refund is too low. User op info. What struct is this? We need to create this. Okay, to create this we need to create this and pass all the functions, or we can just say we can just put a random value. It doesn't have to be. Okay, fuck it. We'll just start function test emit user operation event external where is that external now it's internal function, so we need to expose it. I don't know if there is a better way to go about it. I'll see, but there should be a better way than what I'm doing right now, because writing it every time is just a hassle. Override, no, not override, external expose, and then we'll say not returns. Um, we can just call it emit and then pass all the values. So op info success actual gas cost actual gas. Okay, so that's And next is this, so it also needs memory info. Let's just create, yeah. So there is a way to like optimize or refactor the things, uh, refa- refactor the tests, where you can create like a modifier. If there are like similar parts in multiple tests, you can create a modifier and add the modifier here, and it'll use it. What can it'll set the state for you every time. So instead of, or you can also create a function which is create m user op m user op and user op info internal, which returns entry point dot. Let me test it. No, not this. Dot, and then we can use like struct, I guess. Comma. Okay, what's the error? We can call it memory. Yes. Then entry point dot m. Let me go back. What what was memory? Not m. It's memory. Memory user of memory. Will say we first need to create entry point dot memory user of memory m user of equal to entry point dot memory user of, and then put all the values send. Let's just put it here on the side. Close this for a minute. What is this? Sender, then nonce, then verification gas limit, call gas limit, paymaster, verification gas limit, paymaster, post, yeah, post of gas limit, paymaster, max fees for gas, max priority fees. Okay, then give it random addresses, not random addresses, but like address one, then nonce, sorry, not comma, not semicolon, nonce equal to 1. You can set a value to like any random value. I'm just gonna like 20, 25, 26, 27, 28, 29, 30, 51, semicolon. Okay, was error expected 10. Sender nonce verification gas. P verification is not there. So here P verification gas. Okay, change like 29. Again, why is okay? This is an address. Address equal to 2. And then next is entry point dot user op info memory user op info equal to entry point dot user op info, which is m user of equal to m user of. Next is user operation hash equal to x 1 2 3 4 5 6. Hash doesn't need to be correct, and just we are just checking if the event is correct. Event is sending correct data. We are not checking if the correct data is getting sent to event. That's a different thing, and we don't need to think about it. 32 context offset, 33 pre-op gas, which will be 34. Okay, semicolon, return what was it? What it first returns op info and then user op info and then m user of. Okay, now this is done. We can get them here. What was the name? Create. Okay, create m user of, which will return entry point dot user of info memory user of info comma entry point dot memory user of memory and then m user of. Okay, that's there. We can call entry point dot expose emit user operation and pass it user of info comma true comma 1 2 3 comma 4 5 8. vm dot expect emit equal to, let me check how many of these are indexed parameters. So we yeah, so we know all of them. Where is yeah, we are here at the bottom. When true, 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 comma, address of entry point. So we are saying we know all the three indexed parameters, and we know all all the unindexed parameters along with the address from which the event will be emitted. Next will be emit entry point dot user operation event. Oh, sorry, this should be I entry point because okay. Now first is user of dot sorry, user op info dot user op hash. Then user of dot sender. Then user of dot paymaster. Next is I guess nonce. So user of dot nonce comma sorry, this is success which is in user of info dot no, that's not the we are sending that value. So we can just say true and then 1 2 3 4 comma 5 6 7 8 and this should do it. Forge test dash empty. Okay, we can say view, but the test part, so don't really. Not this. Is it which one? Create, yeah. So this one, it's saying you can say you can convert it to view and even pure. Okay. Next is testing. I think people who will be watching this think I'm a dumb uh, person who will like just test everything. But this is just for practicing the solidity because you just need to go again and again uh, and, and be in that rhythm to test the whole thing, and that's how you'll learn. So hopefully that should do. Let's see, let me take a break. So okay, I'm live. Hopefully that should do. Let's see, let me take a break. So okay, I'm live. Okay, so I'm back. Let's see. Okay, the next function is relatively easy, which is emit something. Emit prefund to low. So this, where is this? Is it an I entry point? Yes, it's an I entry point. It needs hash, sender, and nonce. Out of those, we know there are two indexed, one unindexed. Just keep that in mind. Uh, emit emit user prefund to low. Yeah, here function expose underscore emit prefund to low, which will take user of pinfo memory, user of info external, and then we'll just call emit prefund to low. Okay, yeah, emit prefund to low, and now what does this expects? Okay, I guess that works. Okay, so there is no error. Then move like external, then what what we need to do? Okay, we need to do the same thing, that which is what we did above. User of info memory, user of user operation info entry point dot memory, user of memory m user of, and then call create m user of and user info, which is what we did. Then next we no next first call it expose emit prefund to low, then pass the value which is user op info, and then put vm.expect emit true, true, false, true, address, entry point. You understood? If anyone is watching, uh, expect emit needs five. Uh, what we can say, five arguments, out of which four tells what kind of data we are expecting. So for first three are for indexed parameters, fourth is for unindexed parameters in the event, and then last is the address from which the event will be emitted. So that's what we did. We know two of the parameters, and now let's put I entry point dot user operation. Let me go back. User operation. Yes. No, this one too low. Now it expects user operation hash, which is an m user op. Yes, m user op dot user operation hash, comma. It expects an address, sender address. So it's still same. So m user op dot sender, and then nonce, which is still same, m user of dot nonce. Okay, was there here? Really? Oh, okay, sorry. So this is an user in. Okay, now that's done. Let's first copy the name, change the name, and run it. And it runs. Let's see if all the rest we have written are running correctly. Not needed, but as yeah, we have written multiple tests, and it should be correct. Okay, so now these two are done. What was the next function? Okay, let me run the coverage. We had like 8% something yesterday. I think 12. Yeah, we had like max percentage coverage was 12, and the rest of were in one single digit. Let's see how much it has improved. Command is forge coverage dash dash match contract, which is entry point dot test, and it will just run that and show the coverage for everything. Yes. So yesterday we didn't have this 14 and 25. Here it's still low because we know we haven't gone into complex or bigger functions. That's why line number is low. Yeah, we have improved here from yesterday. Okay, so next function we can take is compensate execute user of. I don't want to touch that right now because it creates an issue. Okay, get required. Yes, this is a easy one because we already have m user of. We know like how to calculate this and what value to expect. So let's see. Well, let's actually calculate it. Again, this is internal, so we need to make it. We need to expose it. Return underscore get M user op. Yes, that works. Now we can go at the end of the file, function test, get, what was the name? Get required prefund. Get required prefund external now we do the same thing again, just we don't get the user op info, instead we just get the second part, memory user op comma memory m user op and call create. That works. Now you can calculate it. Expected pre-fund equal to m user op dot verification call paymaster pre verification call. No, what was that? Call gas limit pay paymaster verification gas limit plus paymaster post of gas limit plus pre-verification gas. Now put them in parentheses and multiply them with base max gas fees. M user op dot max UN256. Now we will put like vm dot assert equal to x, sorry, and we want dot expose pre-verification, yeah, and then pass m user op my expected prefund. Will this work? Don't know. We'll test it. That's why we are here. Test dash empty. Let's see. Yes, it works. It's saying we can convert this to view. Yes. Yup. Go to Solidity matrix. Was this? Validate account prepayment. We have tested this. We have tested this. Have we tested this? Oh, we have get get validation data, validation, compensate, emit. No. So not validate. Okay, validate prepayment, and here validate prepayment and validate account prepayment. So they're, yeah, they're using inside these two functions are getting used inside this function. Get user operation. Let's see what this takes. Okay, this also looks good. We can access this. Let's see, data dot offset. No, we can only access it here. I think data dot offset. Again, don't know what I'm doing. So I can be wrong. I can be right. Then yeah, it's just reversing both things. Delegate revert. Let's see what this function does. Helper method for dry run test. Calling this dev. Calling this method. Yeah, calling this method. The entry point will make a delegate call to given data and report via revert the result. The method always reverts, so is only useful off chain for dry run calls in cases where state override to re- in cases where state override to replace actual entry point code is less convenient. Okay, target, then it creates. I don't know how to test it. I don't have light test idea, but we can do this. I'm pretty sure. So these two are just, I don't know how assembly works, and that's why I'll read about it and we'll test it tomorrow. For this, for this, we can run it, but we need to see how to set base block fees. So foundry book, foundry book. Okay, let it load. Then we'll see what to do. Yeah. Okay, till then we'll come back, and this was the function, right? It's here. It takes max gas fees, priority gas fees. If both are same, then max fees will be returned. If both are not same, then it will take max fees per gas, comma max fees plus block block base fee, and whatever the minimum is. Okay, so there are two conditions here where we get max fees or max fees plus like minimum of those two. We can also create like three conditions to check. We get the block base fees also. Okay, so this is loaded. Now what to like it's not working. Cheat code references environment and then block fee. No, block not base fee. Base fee. And can we do we have a cheat code for it? Cheat code. There is this gas fee. So no, this is transaction. This is gas fees, not base fees. Okay, fee. Yes, yeah, it was the first one. So we can set this and check if we get the value. So let's come back here. Let's first expose it. Expose. Then return. Okay, this should work. Now we'll function test. Okay, external. Now we need to again just get the memory user op user op equal to create. Now expected is vm dot assert equal to user op dot max fees for gas comma expose underscore entry point dot expose. Did we mess up somewhere? Yes, we did. External. Now come back here. Expose. Get m user op. Now we will set m user op dot max priority fee is equal to mu max fees per gas. Condition 1, both fee values are same. Okay, then we have condition 2, max fee per gas is lower than priority. Where here we are gonna change it to like 500. We know that's not the case. And then we need, okay, we need the same thing. Now we'll change max fees per gas to 1000, and we'll expect max priority fee per gas plus block dot base fee, and we can cap it to view. We can restrict the visibility. Yeah, visibility or access. I don't know. We'll change the visibility to view. Then yeah, all three should pass. Yes, all three are passing. And why we did it is like this is one. Then in this min uh, block, like there are two values which can change. So either this value or this value. So we have tested this. Let's go to this and see what else is remaining. For post execution, it returns actual gas cost, actual gas into gas price, and it calls pmaster actual gas plus pre-gas minus. Okay, no, it will resolve this value first and then add it to this. Okay, this is way too big to test in the remaining time. 6 minutes are remaining, so let's figure out something simpler. I made execute. We have tested this. Paymaster we haven't developed yet, like written developed, yes. So we are not going to touch that. And for this we need the factory, which we haven't seen yet. So sender dot code equal to not 0, already constructed. Create sender, and we need all these things. Okay, no, that's not. We have done this. Okay, we haven't done this. Copy to user operation. So we need to construct a fact user operation and pass m user op, unpack unpack paymaster static fields. Okay, and then we can set paymaster offset to wrong and see if it reverts. It if it reverts. Yeah, we can do it. But we also need to check. Like we don't need to check, but it's better to check all the m user of fields are set correctly, which is where the issue arrives because this function doesn't return anything. So we need to in the harness function contract, we need to create a memory user op function. So you can see m user op. Let me see how this is used, then I'll understand. Okay, so they're pass. So what we can do is expose the copy user op to memory, and that expose will return us the m user op, so we can check the values correctly. Right now I'm just gonna write the harness function and then move on, like close the stream, and we'll come back to this tomorrow. So the idea is to do like function expose, do this. Okay, no, do this, change it to external pure, returns memory user of memory, and then return underscore copy, sorry, underscore copy user of comma m user of. No, sorry, we'll create this here. Output info. What's output info? It doesn't have to be anything. We can just create like memory user of memory m no, and remove this and then say m user of return m user of. Okay, that's done. We'll test this function tomorrow and then move on to writing things related to simple account simple account contract or simple account. What did we call it? Simple account. So basically the functions that are related to account contracts, like this: validate account prepayment. So they'll check uh, if the simple account contract returns correct value, or that's what I remember. But let's check. Yeah, calls validate user of and returns the validation data. Yes, so we're gonna test that tomorrow.